Welcome to our lecture series on statistics. Today we'll be dealing with standard deviation as a measure of variability. By the end of this video, you should be able to understand what standard deviation means in your statistical analysis. Secondly, you should be able to compute standard deviation using SPSS and appreciate the use of standard deviation in your statistical analysis. Measure of variability, also known as measure of dispersion, establish a single value that shows how close or far away observed values in a data set are from the mean. In other words, measure of variability is the average distance between the observed values in a data set from the mean value of your data set. Unlike the measure of central tendency that locates the center of the data set, variability measures the spreadness or the dispersedness of the data set. Measure of variability, therefore, establish a single value that represents the spreadness of the data set. There are different types of measure of variability. We have the range, which is computed by subtracting the lowest value from the highest value in a data set. That is when the data is ungrouped. But when the data is grouped, it is calculated by subtracting the lowest class limit of the least group from the highest class limit. In other words, it is determined when the data set is grouped, it is determined by subtracting the lowest class limit from the highest class limit. This range is not actually being used because of it sideline other data within the data set, other values within the data set. Then the second measure of variability is the mean deviation. The mean deviation is just the summation of the deviation from the mean divided by the number of entries. In other words, it is determined by taking the average distance or average deviation of the data set. This is when the data is ungrouped. But when the data is grouped, it is determined using the product of the summation and the mean and the deviation from the mean divided by summation of the frequency. Most of the time, the mean deviation is always equal to 0 when computed, especially when the data is not large. And even if the data is large, sometimes the mean deviation is always very little. It's very small in size. So this weakness led to the use of variance as a measure of variability. However, variance, which is denoted by S squared for sample variance, is computed using this formula when the data is ungrouped, or computed using this formula when the data is grouped. But we also have population variance, which is denoted by sigma squared and computed using this formula when the data is ungrouped and calculated using this formula when the data is grouped. But the problem with the variance is that the output is always relatively larger than even the mean itself. So working with such large value as a measure of variability is unexplainable. So this led to the introduction of the standard deviation, which is the square root of the variance. The square root of the variance reduces the cumbersomeness of the output of variance. So, and standard deviation is denoted by S for sample deviation or sigma for population deviation. And it can be calculated using this formula. For sample deviation, we will have the square root of the variance. This formula is for the variance. For sample variance, when the data is ungrouped. So this square root here is just the square root of the variance. It gives you our product of standard deviation. Or it can be calculated using this other formula, for population variance, for population deviation, I mean. Or it can also be calculated using this formula when the data is grouped. When the data is grouped, or for population variance when the data is grouped. Now let's take a look at this data here. We shall use this data to compute the variance and standard deviation of this data. To compute our standard deviation in SPSS, we open and type in the data. After typing the data, then we go to variable view and format the data. This is student score. We can just say std score without spacing. Then we come to the label and set student scores. Then we go to the measures and indicate it as scale. Then we go to analyze. Then we go to descriptives and we go to descriptive statistics. We click on descriptive statistics and this variable box appears. Then we transfer our variable to the variables box, click on it and transfer it to the variable box. Then we click on option, and by default the mean, standard deviation, minimum and maximum have already been ticked, so we can decide to remove those ones we don't need, like the minimum and maximum. We can also include the variance and also include the range. Then we click on continue, then we click on OK and wait for our result to be out. Now this is the output of our results here. Number of entries is 10. Then this is the range is 8. The mean is 9.8. Then the standard deviation is 2.39444 and the variance is 5.733. So what does this standard deviation mean? It means that the observed values have a distance of 2.394 at average from the mean. So therefore we can interpreting our mean, we can use this as to say that the observed value are very close to the mean, because larger standard deviation means that the data are widespread, they're spread out, and lower standard deviation means they are very close to the mean. So the standard deviation here, interpreting it, means that observed values are very close to the mean. Thank you very much for listening and have a wonderful day. I hope you have already subscribed to our channel. If you haven't done that, make sure you subscribe to Sajas Academy TV. Just go to YouTube and search for Sajas Academy TV and click on the subscription button, and as well turn on the notification so as to get notified once we drop in a new video. Thank you very much. Have a wonderful day.